So in this tutorial, we're going to look at the ubiquitous box and whisker plot. You'll see them in many journal articles, in many reports, and they really help us to demonstrate the spread of data for a numerical variable. And it does it so by the use of the quartile values, and they're also very useful to help us indicate possible statistical outliers. So I'm here in RStudio, and what I've decided to do in this little tutorial is just to show you the actual RStudio environment as opposed to the RPubs document, which was already rendered as an HTML file. So remember, we'll have the YAML up there, the markup language that tells the page how to render and what should be in it. And we're going to render to an HTML document. The table of contents will be set to true, and we're not going to put any numbers to the section. In the first code chunk here, I'm going to put the libraries that we're going to work with. We're going to work with the Tibble library. So if you haven't got that, go to packages here and install that package by hitting install and typing in Tibble. Same for DT, that's data table. And of course, we're all here because we love Plotly. Next up, I always just style my HTML file with a bit of CSS code, cascading style sheet code there, and all I'm doing is the H1, the H2, and the H3 headings. Remember the H1 headings, that's the largest type that a web page will just put on your screen as far as just the normal text is concerned. H2 will be slightly smaller, H3 even smaller, and it goes down to H6, and then of course just normal text. So I like to put in some hexadecimal codes there for my colors, the 3 colors for the 3 text sizes. That's it. And then I also have my logo up there. This is how I put in the logo. I don't put any placeholder text there, so just open, close square brackets. And then, of course, this PNG file lives in the same folder as this notebook, so no problem there. So you can read up a little bit about the introduction if you view this page as a rendered page on my RPubs website or page there at least. And remember that this file will always be available on GitHub, on my GitHub repository as well. And the links to all of this, of course, down below. So read up there. What we're going to do here is just to generate some random values for 3 variables. And in case you've never done this, because I always just run through it very quickly, I've put quite a few comments to the code here. So if you want to just read what every line of code does, it's all out there for you. What I like to do is just to use the set.seed function, and I just put an integer there, in this instance 1234. That just means if I run this code over and over again, I'm going to get the same random values back. So it all looks the same every time I run it. So first I'm going to create 3 list objects. I'm going to call the computer variables income, stage, and country. Income is going to be from a random, it's a random variable from a normal distribution. So we're going to use the rnorm function there, and we can see the rnorm function there takes 3 arguments, 500. I want 500 random values from this normal distribution with a mean of 10,000 and a standard deviation of 100. But you can see I've wrapped this as a first argument for the round function, comma, the second argument is digits equal 2. Because income, it's in cents, so I want two decimal places there for the values that I get. Stage is going to be a nominal categorical variable, and I'm going to use the sample function for that. And then I'm going to pass it the string vector as the sample space from which to draw these random samples. So the C function there, and I put the 3 values early, mid, and late in there. So that's my vector there. That's my vector there of strings. And then that's the first argument for sample. The second argument is how many I want. I want 500, and I always have to say replace equals true, because if I draw 1, say for instance I draw late, it's got to be chucked back in the bowl so that it's available to be redrawn at random. And we're going to do exactly the same for country. Again, it's a sample. We see the sample space there of my country variable, and again 500, and replaces true. Now I'm going to create a tibble. Remember, a tibble is just a more modern form of a data frame. It's not going to create factors from my categorical variables, and it prints nicer to the screen if you render to HTML. So just use tibble there. I'm going to create 3 columns, an income column, a stage column, and a country column. You see the uppercase letters there, just to distinguish them from these 3 list objects that I created. And I'm actually going to pass those values to these columns. Now remember, these columns with uppercase, that's my variable name, and we're going to refer to them when we create our plots. And then I'm going to use the data table function, and that's from the DT package. And that just prints a very nice table when you render something as HTML. When you render it for the web, it really has a nice search bar, and you can go from ascending to descending order, and you can see all the different pages of data. So it's a very nice package just to render spreadsheet type data, a data frame or a tibble to the screen. So if we run all of that, there we go. What I should probably do is, there we go. On the right-hand side there, we can see the viewer, and that's really what it's going to look like. It's a very nice, this data table when it is rendered to HTML. So let's create a simple box and whisker plot. So all we want to do is to look at this income variable, this 500 values, and create a simple box and whisker plot. And I'm going to store it as a computer variable P1, my first plot. The function is always plot underscore ly, and I'm just going to pass the arguments directly. Remember, I could have just added another trace, but we've just got one here, so let's pass all my arguments just to this function. First of all, type equals box. These are keyword arguments. In other words, they have names, so it doesn't really matter in what order you place them. So type equals box, so box plot. On the y-axis, I want income. Always remember the tilde. And I use the uppercase I, which means I'm referring to the tibble, the data frame, so I better tell it that the data is in this df data frame that I created. So if I used the lowercase, it would have just referenced the list, and I don't have to say this comes from this data table or this tibble. And then I'm going to give it a name, all income, and I'm piping this to the layout function because I want a title, and I want something on the x-axis and y-axis. On the x-axis, I want more than one thing, so I'm going to pass those as a list. So the title is nothing, no title there, and the 0 line is false. So on the 0 line, I don't want that drawn to the screen. And you can see the y-axis is going to be income. And let's print it out and see what happens. It's going to print here in my viewer a lovely box and whisker plot. So let's have a look at that. We see the overall income. I put all income on the x-axis because it's just drawing it from this name that I gave it there. That's why I didn't put in a title. And then income here on the right-hand side. And you can see it's been marked as 7,000, 8,000, 9,000, 10,000, etc. So what is this box and whisker plot all about? In case you didn't know, the box in the center has these 3 lines. The lower line is the first quartile value. And you can see there, Q1. And you can see it's at the value there, 9,325.805. That is going to be our Q1 value. The second one here is the median, and you can see there the median, or the second quartile value, and the upper edge of this bar, this box I should say, is the third quartile value. And then you can see these whiskers go up and whiskers go down, and what is happening here in Plotly is this upper limit and this lower limit will either be the minimum or maximum value if there are no outliers beyond that. But if there are outliers beyond that, this is going to be 1.5 times the interquartile range. Now remember what the interquartile range is. That's Q3 value minus this Q1 value. You multiply that by 1.5, and you add this to the Q3 level, and you subtract that from the Q1 level. And then you place these. And anything beyond that we see as statistical outliers, and you can see they are nicely plotted there for us. If everything fell within those, then of course either of these whiskers would just be the maximum or the minimum. But there are outliers beyond both, so you can see this will be 1.5 times the interquartile range above this and 1.5 times the interquartile range below. And that's why you sometimes see these interquartile ranges, these whiskers I should say, one longer than the other, because you think, well, it's some fixed distance away from the upper and lower quartile. Well, that just depends on whether this is minimum and maximum, or showing the interquartile range itself. Now, many times we just want to plot this on its side, so a nice horizontal plot, and all we have to do, there are more ways to do it, but the easiest way to do it is just to change it from the y-axis that we had there. So income is on the y-axis, now we place income on the x-axis. That is it. That's all we're going to do, and then remember we should just put this income on the x-axis now when we plot that text. And if we run this code, we see it's just nicely plotted on its side. So I've put income on the x-axis here as far as the title is concerned, but I just changed this to x, so the numerical variable is now actually on this, drawn across the x-axis. So that's very simple. Now, sometimes we don't just want these outliers plotted, we want all of the data points plotted. Now, this is not going to look so nice because there are 500 of them. But the way we can do that is to say box points equals. Now, there's a couple of these arguments we can use. I'm just going to say all. I want all of them. But if they're all printed on the same line, you can imagine that you're not going to see all of them. Some will be plotted right on top of each other. So we add a little bit of jitter so that they plot next to each other, and we're only going to set that to 0.3, and then the point position, -2, that shifts it to the side of the box. Let me show you. Let me show you the outcome. There we go. We put this on the y, so it's going to be to the left, -2 to the left. You see all of them there. There's a bit of jitter, so it prints left to right. And you can see all the values there, all 500 of them there. What if we want to add a mean and standard deviation? Because remember, these are just the quartiles that we have here. I can add this keyword argument box mean, and if I set it to SD, it'll actually do the mean and the standard deviation. If I just say box mean equals true, it's just going to draw the mean in as well, but I always put it to SD, so then we have the mean and the standard deviation, and it's going to do these dotted lines for you. That's what it looks like. So you can see the mean and the median is very close to each other there. The dotted line is very close to the median line. And then this diamond, where it intersects with the whiskers, that's actually indicates to us the standard deviation. Great stuff. Now let's create more than one box plot. And seeing that we are dealing with a tibble or data frame, we can just split it up by some categorical variables. So on the y-axis, I still want the income. So it's going to be this upright. But I'm using the color equals, and then that's got nothing to do with the actual color, like in red, pink, blue, orange, etc. It's the keyword argument for splitting the numerical variable up by the sample space unique data point values in this categorical variable stage. So let's have a look at that. So remember, there were three unique data point values in the stage, in the sample space of the stage variable. There was early, late, and mid. And now you can see the numerical variable is split up along those three that it found. So that will be income only for data point values that are early in the stage, late, and then the mid there at the end. Now we can be even fancier than that. We can first split it up by the country. Now look at that. I say X equals country. Remember, there were two. There was Canada and US. So it's going to split it up by that first and then by the color. So for each of the two countries, we're going to have all three stages. And what we have to do here is in the layout, add the box mode. And I'm going to say group them, please. Now you might get a warning, an error message saying that box mode is not a keyword argument in layout. Indeed it is, and it does work. So I've come here and I've disabled show warnings and show messages, and you can see it there, message equals false and warning equals false up there. And let's just print it out because indeed it does work, no problem there. So now we can see it's country, and then each of these are early, late, and mid. And always remember with Plotly, I can turn on and turn off some of the values that I do want or don't want. So let's turn that back on. Let's turn mid off. Now I only have early and late. It is really fantastic. I just love Plotly. Now, let's just play around a bit. What I've got for you here is just to change the outlier marker shape. And if you go on the Plotly website, you'll see there are plenty of shapes you can give. So I'm going to say marker. I'm going to bring in the keyword argument marker. And as a list, I've got to pass everything as a list, even though I only have one. I've got symbol equals square dot. square dot. Let me show you what a square dot looks like. So those outliers are just tiny little squares. Sometimes that looks a bit better because our box is a rectangle. Anyway, let's just change the colors a little bit. I'm going to stay with the square dots. I'm going to use the full color argument. I'm going to set that to a word, one of the words that are allowed, and that's pink. And then the line, that's this outlier line here, or not outlier, this outline I should say. I'm going to make the color gray, and I'm going to make the width 2 pixels. So let's have a look at that by just adding the full color and the line keyword arguments, and I see this nice pink, and I see this gray outline that we have there. Of course, we can just choose. Let's just write choose correctly there, choose. Of course, we can choose a color set, and there I'm going to use the colors keyword argument. So remember, there's color that is just going to split by the sample space of a categorical variable, but colors, that's the actual colors, and there are a couple of these named sets. You can find them on the Plotly website. We're going to go for set 3, and there definitely are set 1, set 2, and set 3, and some others, and you can see this nice pale green and this pale yellow, and it's split it up by that. So really, box and whisker charts are ideal for your numerical variables, and at least to show the spread in the data, and you can split that up by various categorical variables.